This is a common sight for us up here in the land of 10,000 winters. If you're like me and have a less snow-compatible vehicle like a Prius, you know how frustrating it is to be limited to going out once the road is plowed, or what it's like to jump the gun and go out before the road is plowed and get stuck. For us to get to work, we need that road cleared. I study osteosarcoma, the most common primary bone tumor in humans and dogs. Bone tumors have more in common with the Minnesota blizzard than you might think. Like snowflakes, each tumor is unique with a variety of genetic adaptations and cells making up the tumor. Like a snowdrift at the end of your alley, a congregation of cells can be problematic. And most importantly, like snow blowing in the wind, cancer cells spread and land in new locations, in osteosarcoma, most commonly in the lungs. For reasons we don't understand yet, osteosarcoma cells in the lungs are often able to resist chemotherapy. For patients who present without visible metastasis or spread, the prognosis is relatively good. As many as 3 in 4 of these patients are still alive 5 years after diagnosis. However, for patients with visible metastases, that survival rate plunges precipitously. Less than 1 in 5 of these patients is still alive 5 years later. Unfortunately, this tragically low survival rate has remained constant despite dozens of clinical trials. Why do so many new drugs look promising and then fail to translate into effective therapies? My research seeks to understand how the tumor's physical environment contributes to chemotherapy resistance and to develop a better animal model to test new therapeutic approaches. We know that some tumors are rich in a molecule called hyaluronin, and that hyaluronin increases the pressure within the tumor, constricting blood vessels carrying chemotherapy. So think of hyaluronin as the snow covering the road, and the chemotherapy is this Prius, which is going nowhere fast. However, we can treat with a hyaluronin digesting enzyme called hyaluronidase, and it acts as a plow opening up that road. We can also prevent the formation of hyaluronin with certain drugs. Think of them as a road with radiant heat built in. We know that this hyaluronin roadblock occurs in primary osteosarcomas, but we don't yet know if it occurs in the lung metastases, whether they'll produce hyaluronin, whether they'll respond to hyaluronidase or to blockade of hyaluronin synthesis, or even if we have the best animal model for the job. My research approaches this problem from several angles: creating a mouse model of osteosarcoma spread, evaluating chemotherapy uptake and processing, and characterizing what drives hyaluronin production. With a better understanding of how hyaluronin snowdrifts impact chemotherapy traffic, we can develop a next generation plow and improve the survival of patients with metastatic disease. Because less than 1 in 5 patients surviving to 5 years, we can do better than that. Hyaluronin blocking chemotherapy is just another snowy commute. We just need to build the best plow for the job. Thank you.